In Pre-Calc 20, we'll be working with quite a few complex functions throughout all of our units. The need to become very proficient in this factoring of our basic and our composite functions is going to really be essential for your success. The composite function, just an overall function that has another function embedded into its form. They'll typically look more difficult compared to the ones from last year that we did. And we're going to use some skills to help us get around that. So in our first one, we're going to factor some difference of squares. So in this one, we have a 2x to the power 6 subtracting a 288 over 25. Now, it may not look completely intuitive, but we can actually factor a 2 out of each of these terms. When we factor a 2 out of an x to the power 2 out of a 2x to the power 6, we just be left with an x to the power 6. When we factor a 2 out of 288 over 25, well, factoring is like a division. So dividing by 2 actually means that we just be multiplying by the reciprocal. And because we are now multiplying, we can reduce. 2 goes into 2 once, and 2 goes into 288, 144 times. Which means when we factor a 2 out of this fraction, we'd be left with a 144 over 25. Now, this is actually a difference of squares. We have a square, so something that we can multiply by itself to give us x to the power 6, and we can multiply something by itself to give us 144 over 25. Just bring down our 2. Difference of squares is really nice and easy. We just make our 2 sets of brackets. The square root of x to the power 6 is an x cubed. And the square root of 144 over 25 is a 12/5. Make one positive and one negative. And really, since we can't really take an x to the power of 3 or a 12/5 and take their square roots nicely, we're done. This is our final answer. When we do an x to the power 4 subtracting a 256y to the power 4, well, we make 2 sets of brackets. The square root of x to the power 4 is an x squared. And the square root of a 256y to the power 4 will be a 16y squared. Make one positive and make one negative. What we can then see from here is we have a square adding another square, which means that this factor right here is prime. This binomial is prime. So we can't really do anything more with it. It would just be an x squared at 16y squared. But we can do more with this one because we do have a square and we're going to subtract a square. So this is another difference of squares, which we can simplify for much further. Well, not much further, but one more step. The square root of an x squared is x, and the square root of 16y squared would be a 4y. Make one positive, make one negative, and we can finish off here because even though we can, in all reality, we can take the square root of an x, it's much more difficult. Well, not entirely more difficult, but it's not common practice to factor this any further because it's not really perfect squares. It's an x and a y. Even though we can take the square root of 4 because it's directly attached to that y, we're all done. When we're going to do these difference of squares, we're going to do all these the hard ways. On our next page, we're going to do some of it a little bit easier. For example, here, we have a 3x plus 5 squared subtracting 16, which means we actually have a square and we are still subtracting a square. The square root of a 3x plus 5 squared is just a 3x plus 5. the square root of 16 is 4. We make one positive and we make one negative. The last step that we really need to consider right now is that we have to combine like terms. A 5 and a 4 are like terms, and a 5 and negative 4 are like terms. So we have a 3x plus 9 and a 3x plus 1. This example can be done further because there is still something common in one of these binomials. We can factor a 3 out of a 3x and a 9. When we factor that 3 out of this first binomial, we'd be left with an x plus 3. We can't factor anything further out of 3x and 1 because there's nothing common. They're relatively prime to each other. 3x plus 1. And that's our answer. In this one, we're going to have a really essential step and a really essential skill that we need to learn. The great thing, though, is we have a 2x minus 1 squared and a y plus 4 squared. They're both perfect squares. So we can make two sets of brackets. The square root of 2x minus 1 squared is 2x minus 1. The square root of a y plus 4 squared is a y plus 4. Make one positive. This one is easy because when we're adding something, we're not changing anything. But on this one, we are subtracting. More specifically, we are subtracting all of this y at 4. We haven't had to consider that because when we were just adding 4 or subtracting 4, adding 16y squared or subtracting 6y squared, or adding 12 over 5 or subtracting 12 over 5, those are all one term. In this one, we have an entire y at 4 that we have to add or subtract. Our next step to this is simply combining our like terms. We have a 2x and a y. I like dealing with my variables first, so I literally just have 2x plus y, and then I can combine my like terms here. My 1 and my 4, or more specifically negative 1 add 4, is adding 3. In this second set of brackets, though, we can treat it either way, or in two ways. Either we can treat this subtracting a y add 4 as literally subtracting y and subtracting a positive 4, or what we can also do is treat it as a negative 1 in front of a y add 4, which sometimes can make things a little bit easier because then we can distribute a negative 1 inside and we still get a negative y subtracting 4. Either way really is fine. It's just going to help us combine our like terms a little bit easier. So 2x subtract y, and negative 1 subtracting 4, or negative 1 subtracting positive 4. Either way works. It's just subtracting 5. There's nothing common between a 2x, a 1y, and a 3, and there's nothing common between a 2x, a negative 1y, and a negative 5. This one is fully factored. Our example here, again, we have some squares. But we can't do the square root of 27 nicely, and we can't do the square root of 108 nicely, which means we go back to our first step to factoring. Is there something common, a greatest common factor that we can take out of a 27 and a 108? Absolutely there is. It's 27. When we factor a 27 out of this term, we would be left with an x plus 3 squared. When we factor a 27 out of this term, we'd have a 4. And we still have this 2x minus 3 squared. when we are factoring, we're only considering what we can take out of each individual term. We only have to take it out of each term once. Just like in this one, we only had to take it out of each of these terms. If we go back to our grade 9 understanding of what a term is, it's just anything that is separated by an addition or subtraction. Because this is 27 being multiplied by this x plus 3 squared, that does not separate these two things from being different things. They are a term. But within this one term, we have a binomial, which is two terms. There's nothing common between an x and a 3, and there's nothing common between a 2x and a 3. There is something common between the 27 x plus 3 squared and a 108 2x minus 3 squared. It's that 27. Alrighty. So continuing on, we have a square. We're subtracting the square. So square root of x plus 3 squared is an x plus 3. Square root of a 2x minus 3 squared will be a 2. 2x minus 3. Second one, x plus 3, square root of that one, square root of this one will be a 2x minus 3. Make one positive, one negative. That allows us to distribute the 2 onto what it is directly attached to simplify and combine like terms. So 27 x plus 3 plus 4x minus 6. Second set, x plus 3 subtracting 4x plus 6 and combine their like terms. Let's see, we have 27, x and 4x is 5x, 3 and negative 6, 3 and negative 3. And in the second set of brackets, x subtracting 4x is a negative 3x, and a 3 add 6 is a positive 9. Are we done? Not quite. Even though there's nothing common between a 5x and a 3, there is something common between the negative 3x and the 9. It's a negative 3. So factoring being that thing that is like division, we're going to divide each of these terms by a negative 3. But we're not going to get rid of the negative 3. We're going to go and put it out in front and attach it directly with that 27 to give us a negative 81. 5x minus 3 and x minus 3. Now, that one is all done. As you can obviously see, these composite functions are way more complex than what we had done last year, and even what we did on a review. Since we have difference of squares, we might as well do all of our other types of factorings too. We've done the GCF, or difference of squares. It's good to practice. We're also going to practice some simple trinomials. So on this one, we have an x plus 3 squared, subtracting a 6x plus 3 minus 16. Well, we're going to do this two ways. We're going to use a substitution method, which we could have also used on the difference of squares. And we're going to do it the hard way. What we're going to do is we're going to use a let statement. We're going to let something equal something in here. And what I mean by that is we're going to actually let some kind of variable, so we'll say y, equal an x plus 3. The reason we're doing that is it's going to make our example look actually quite a bit different. And it's going to make it look a lot easier. As soon as we've said that y is wherever we see that x plus 3, now it really looks like a simple trinomial, which allows us to do our product and sum of 1 times negative 16, sum of negative 6, and get our two numbers of negative 8 and positive 2, so that all we have to do is make two sets of brackets. We have y squared, so we're going to write a y. Subtract 8, add 2. But since we don't know, or we haven't finished up our question, we're going to finish it up. We have y. Well, y is x plus 3. So instead of writing the y, all we're going to do is write x plus 3. That y is x plus 3. This y is x plus 3. Still going to have that subtract 8 and the add 2. And after simplifying, x subtract 5 and x add 5. And this one's done. This is using a substitution method, using a let statement. We can also potentially do this the hard pressed way, which means just doing it exactly as it is. It is totally up to you which way you really prefer. All it's doing is still treating it like a product and sum. All of our information is the exact same. So all of this is literally the exact same information. The only difference is when we have it here, well, we're just going to write it as, okay, we have x plus 3 squared. Well, our first thing is going to be an x plus 3. After that, we have the subtract 8. And we add 2. It still comes out as an x subtract 5. X add 5. I honestly prefer using the let statement for pre-calc 20, just because it helps really demonstrate the understandings, as well as it helps us kind of develop those same skills for when we're going to really use it a little bit later on. Doesn't matter to me which way you prefer. I think this looks slick. At the same time, I know that this is really good. I am going to stick with the substitution method for the rest of these examples. So this one, I'm going to let x subtract 8 equal, well, I'll say y again. That way I have a y squared subtracting a 4y subtract 77. Product of 1 times negative 77, sum of negative 4. Two numbers that would have a product of negative 77 and the sum of negative 4 would be negative 11 and positive 7. Which means in my simple trinomial factoring, all I have to do is put y, subtract 11, and y, add 7. X subtract 8 is y. So wherever I see y here, I put x subtract 8, subtract the 11, add the 7. It simplifies to be x subtract 19 and x subtract 1. And we're all done. Of course, I can't get away with not doing a complex or more complex version. Well, I'll use y. I'm going to let y equal 6x minus 5. The reason that I'm choosing all of these ones is because they are literally the ones that are a repeated function. So I'm going to have a 12 y squared subtracting 156 y adding 144. Our first step to factoring each and every single time is to take out a GCF. I have to take out a 12. Oh, sorry, I don't have to take out a 12, but in order to save you from having to go a product of 1,728 and a sum of negative 156, you're going to want to do that. I factor 12 out of here, I'm good. Let's see, this one should come out as 13. This one would then be 12. Now I can do my product of sum on here, which means I have that 1 in front of that y squared now. I've already factored the 12 out. It's kind of already completely separated from that y squared. We're good now. 1 times 12 is 12. Sum, it's going to be that middle coefficient, that negative 13. Well, two numbers that work. Negative 12 and negative 1. So that 12 just comes down. I'm going to put my y's in. I'm going to have a subtract 12 and a subtract 1. Wherever I see that y, I'm going to write 6x subtract 5. I just put my negative 12 there, my negative 1 there, and I'll be done in 2 more steps. 6x subtracting 17, 6x subtracting 6. Well, we're not done because there's something common between a 6x and a 6. I can factor out a 6. So when I factor out that 6, I get 72. That first term isn't going to change, but this second binomial will. And this is completely simplified. There's nothing common in any of these binomials anymore. Simple trinomials work out really nice. Complex trinomials are really not any harder. Let y equal x plus 7. So I'm going to have 6 y squared subtracting a 1y subtracting a 15. This allows us to make things a little bit easier to work with. Instead of dealing with this entire x plus 7, we're just dealing with one variable of y. Once again, a review of our complex factoring. It's still taking that number in front of the square and multiplying by the constant term, so that a times the c. 6 by 15, doing my math right, should be 90. It's negative 15, so it's going to be negative 90. Sum of negative 1. Yep, I'll get it. Product of negative 90, sum of negative 1, negative 10, and positive 9. Here's our big difference to simple, from simple to complex. That middle term gets broken down into these two numbers. So a negative 10y and a positive 9y. Split her down the middle. And let's do some fun factoring. We can factor 2y out. When I factor the 2y out of a 6y squared, I'm left with 3y. I factor 2y out there, I'm left with a negative 5. I can factor a 3 out of a 9y and 15. So I'm left with a 3y minus 5. The goal of this matter is to make sure that this is the same as this. As soon as those are the same, all we have to do is combine them to be one thing. We are actually going to factor a 3y minus 5 out of this term and this term, which allows us to combine them into one thing. Different groups call them different things. One that's been resonating with me is collect the sheep. I collect the sheep from this group, collect the sheep from this group. Well, I'm going to collect and put them into one group. After that, I'm simply left with this 2y add 3. So here's my group. Here's what I was left with. But we're not done. I know. Mr. Tiny, why can't we be done? No, let's pre-calc 20. Pre-calc 20 is fun. At least I think so. Wherever I see that y, I'm going to write x plus 7. Then I'm going to work on distributing and combining my like terms. So 3 onto my 3x plus 7. It is not being distributed onto that negative 5. It is not attached to that negative 5. It is only attached to that x plus 7. Same thing, this 2 is not attached to that 7, or to the 3. It is only attached to the x plus 7. 15 plus 3. We should be done just in a second here. 3x adding 16, 2x add 17. And we should be all good. There's nothing common between a 3x and a 16, neither a 2x plus 17. Our example here, I'm going to let y equal an x minus 5. So wherever I see this x minus 5, I'm going to write my y. Y squared minus a2y, subtracting 44. Hopefully by now you notice that usually I try and make these last examples here hard enough. What am I doing to make this hard? Our first step to factoring is take out the GCF. Take out the greatest common factor. You don't want to deal with a product of 528 and a sum of -2. You don't. So factor out the 2. It may not look like this one's going to be any easier, but trust me, it does. It is way easier. 6 by 20, -22 as our product. It's -132, a sum of -1. Some people are able to look at their times tables and see that there is actually something very nice here. Our numbers are 12 and 11. More specifically, -12 and +11. So I can take my 2, I have my 6y squared, split my -y into a -12y and a +11y. And then I can factor further. That 2 that I factored out in front, well, it's just going to stay out in front. It's not going to do any more anything more than just stay out in front. We're going to factor something out of my 6y squared and my 12y. I can factor out a 6y, leaving a y, subtract 2. Factoring here, I can factor out a positive 11, leaving myself with a y, subtract 2. Since this is the same as this, I'm good for combining that now. So I can have my y, subtract 2, and be left with a 6y add 11. No, we're not done, because y isn't y is x minus 5. So x minus 5, subtract that 2. This one is going to look a little bit green. But it's all still going to work. My 2 is just going to keep on coming down. Let's simplify what we can. X minus 5 minus 2 is an x subtract 7. Here, we have a 6 x minus 30, add 11. And last but not least, our negative 30, add 11. This is subtract 19. And this is our complex factoring again. Overall, pretty nice to work with. I add in one more skill into Pre-Calc 20. It looks like it's the easiest, but you really can't underestimate it. It really starts with some of our intermediate steps of what we've already done. My main reason for including this is basically past students have told, like, why didn't you just teach this in Pre-Calc 20? Because they're doing it in Calculus 30. It's like, you know what? Why not? It is still dealing with some composite functions, so let's do it. Let's do it. Well, here we have a 5y x plus 3 subtracting 4x plus 3. Two ways we could do it. Hopefully you see that this is actually really nice and simple. You see that x plus 3 and that x plus 3. Well, let's put it out in front. We're going to factor that x plus 3 out of here, that x plus 3 out of here, combine it to be one thing. Then we're simply left with a 5y subtract 4, and that's literally the answer. There's nothing common between an x plus x and a 3 or a 5y and a 4. That one's done. Here, you can do the exact same thing. We see that y subtract 2 there, y subtract 2 there. Well, let's combine it and put it out. Then we're simply left with a 12x cubed subtracting a 24x squared. This one we are not done with, because even though there's nothing common between a y subtract 2, there is something common between a 12x cubed and a 24x squared. That being a 12x squared. Ideally, we put it out in front, so it can be left with y squared, y subtract 2. We factor a 12x squared out of here, we just be left with x. We factor 12x squared out of this one, we're left with the 2, or specifically negative 2. This one is also done. So these are examples of factoring by grouping. Well, we've actually been doing this factoring by grouping in kind of our intermediate steps of this complex factoring. The next example, we're going to actually go back one more step. We don't see any groupings. We never saw any groupings in this step either, but we created it. We split her down the middle. So let's do that. We split it down the middle, which allows us to combine 2y, factor out 2y from there, be left with a 3x minus 5z. And in these two, in order to make these the same, we'd have to factor out a -1. Always make sure you put it as a -1 so that you don't miss that in our last step. Factor that -1 out of there, we're left with a 3x. And out of this one, we have the -5z. Finally, there's our grouping. Let's factor it out. And then we're left with a 2y minus 1. All right. This one, well, this one's a little bit of trick. So just watch this for a second. You don't have to, well, yeah, write it down. Okay. So if we split it down, we see in these two terms, we can factor out a 2. We would then be left with a 3x squared plus 10yz. Out of these two, ideally we want to factor out that negative. More specifically, we can factor out -x. But that would be leaving us with an 8z add 15y. You can tell that this is nowhere close to what that is. No, we haven't done it wrong. We just have to do something a little bit more tricky with. And overall, it's doing a skill that's related to grouping. It's actually regrouping. What we want to do is we want to look at these numbers, look at our variables, and see how can we group them together in some way, shape, or form that is going to be the same. And the easiest way to do it is look at what is proportionate to each other. One thing we can do and see is that this 6 and this 8, well, that's pretty much, the 6 is a quarter or 3/4 the size of the 8. The same thing as the 20, the 15 are within the 3/4 proportion. So what we're going to do is we're going to rewrite this. We're going to rewrite this as a 6x squared minus 8xz. And since we wrote the 6 first, in between these two groupings, we would want to write the smaller number first as well. So a -15xy add the 20yz. Now if we split it down the middle, we'll be able to see that we can still factor out a 2, but we can factor out an x too. We'd be left with a 3x, subtracting 4z. And from these two, we will want to factor out a -5y, leaving us with a 3x, subtracting 4z. Now, we are good to finish off this example. 2x minus 5y, which is what was left here. And that one's done. And there's a whole bunch of factoring by composite functions.